Hi, this is Frederick, and I'm going to show you how to use a file that's on my website now. And this is a likelihood ratio calculator. And so you just want to go on the website and then download it. And hopefully it's faster than this. Okay, here it is. And so there's a lot to look at in here, and this is not the file that I use for myself, but I did put in some information to help orient you for what this file can do for you. Now, I have some tests over here on the left, and then I have some cut scores, and here I don't have some cut scores, and I just use this as an example of a multi-category test. And then I have two different sets of cut scores for the word memory test here. And then I have a couple of cut scores for the TOM, and then I talk a little bit about reliable digit span. And I just want to go through this with you. I'm gonna make this a little bigger for you. Okay, so I'm just going to keep going up a little bit. Now, here's the word memory test, and if you look at this very, I think, great article by Grevord and others, they did a very nice comparison of the word memory test, the TOM, and the PDRT, the Portland Digit Recognition Test. And what's good about their paper is it shows you very clearly that everything is a matter of choice. And so Green has chosen these cut scores for his test. And what they show is that leads to some very high false positive rates. If you choose some other cut scores, which they determined from their evaluation, you get much more acceptable false positive rates. The sensitivity goes down, of course, compared to what Green is touting. So you choose what you want. There's a consequence for using false positive rates this high. And I don't think there's anything good about using tests with false positive rates that high. Okay, so then I just show you that in the same paper you can get information about the TOM. Now, what I probably didn't do is show what they use for the TOM as less than or a 2% rate. I think this is a pretty standard cut score for retention, and I doubt that the false positive rate is really that high, but I think that's what they reported. So then I would say if you're going to choose some different studies, say like the TOM manual, then you might explain why you choose that instead of this more current study. Okay? I think this is always what's incumbent on you, is to show what your cut scores are, what you base them on. You don't have to use the Grevord study. You can. I don't really think you can get this information from the word memory test manual, but there's other papers that talk about the false positive and true positive rates of the word memory test. You could use those. And then I think that your job as an expert is always to explain the basis for your decision. Okay? Now I'm just going to skip down here to the reliable digit span as a test, an embedded test of malingering or effort. I don't really think it's good to call it an effort test. It's probably an intention test. But what I really like about this paper by Schroeder et al. Is that it's an effective analysis of many studies of reliable digit span. The use of the cut score less than or equal to 7 is just a bad decision in my view, especially based on this paper, which shows that this is the more conservative test with still a 5% false positive rate, relatively low true positive rate, but what you get from going to 7 in sensitivity is far offset by what you get in the increase in false positive rate. And then finally, I look at the VIP, the validity indicator profile, and because it has categories of suppression, irrelevant, and inconsistent, each of which represents a type of invalidity. If you look at Table 9 in the VIP manual, you will see that 6% of people, let's go back up and show this as true positive rate, 6% of people who are suspected of feigning get a suppression score, and there is a false positive rate, not zero, associated with that. And so these are low numbers of both catches and false alarms. The next category is irrelevant. If you're going to do irrelevant, then you're going to include all the suppressions in there, okay? So this catches both suppression and irrelevant, gives you a sensitivity of 0.503, and the false positive rate, of course, increases as well. And then again, if you're looking at an inconsistent VIP finding, it's going to incorporate all three of these categories. The sensitivity then is 66%, false positive rates 10%. Now what you do, let me just show you what you do for this file. Is you're going to, let's say that you use this, okay? Let's say the word memory test, you're going to get an 80, 75, and a 75, okay? Well, what's the decision? Well, 80 is a pass. You're going to put pass in here. And then it's going to calculate a likelihood ratio for you. The likelihood ratio is a negative likelihood ratio, which means the odds that the person is faking are now reduced by 1/2. You multiply the odds by 0.53 to get the new odds. Now here, this is a fail. Okay, and now the odds are increased by a factor of 26. And overall, you would see that's like an increase of 13. This is a pass. And now, so if you're giving this test, you might say, well, what are the odds? Or what's the change in the odds or the likelihood ratio? Now, in this column, we're just going to multiply all the likelihood ratios by themselves. We get 26. Here, we're going to multiply all the negative likelihood ratios by themselves. We get 0.4. We're going to multiply them together. So you see, based on the performance of the word memory test, they're according. This is according to Greaves data, Grieve et al. The odds are increased by 10, a factor of 10. And so if you you had pre-test odds of 40%, which is a standard neuropsych idea that 40% of feigning, 40% of forensic neuropsych cases are feigning, then your post-test probability is 87.87, which is a very good increase. You've gotten a lot of knowledge there using these very conservative word memory test scores. So here's what happens is you change your you have to come up with some pre-test value of what you think the rate of feigning is. In your sample, if you say it's 40%, that makes pre-test odds of 2/3. Multiplying by this value, now you're going to get your post-test odds, which you're going to convert to post-test probability. I think there's some instructions over here for explaining that. But all you have to do is really just type in these words and see the language that's written in there just tells it what to do. So here's what you have to come up with. Based on your research, you have to come up with the test that you're interested in. You have to come up with the cut scores that you're going to use. You're going to have to come up with the true positive rate and false positive rates. You're going to then enter your scores as a way to show how you made your decision. Here's your decision. 80 is greater than 70. That's a pass. 75 is less than that. That's a fail. And then this stuff happens automatically for you, and then it automatically goes down here. Now, what it says is if it's pass, here, if this is a fail, then you just let it equal to what? If it's a fail, it's E3 divided by F3. Okay? If it's a pass, it's going to be 1 minus E3 over 1 minus F3. Otherwise, it's equal to 1. And why would we just let it equal to 1 if you don't give the test? Is simply because 1 times anything is itself. So if you didn't give the test, the likelihood ratio just stays at 1. These column products happen here, and then your overall likelihood ratio is the product of these two categories. Okay. If you have any questions about this, just shoot me an email. My email is on the front page, the home page of this website. Hope that's helpful to you. Good luck.